Hello, students. Welcome back. We are going to work on solving radical equations today. So those are going to be equations that have roots in them, square roots or third roots. I tried to, here at the beginning, give you an idea of the different types of equations. So a power equation is going to be something like x squared equals 36. And we just worked on those types of equations where at the end you would take the square root of each side and get x equals, and we actually would get two answers, either positive 6 or negative 6. And so the inverse of that would be to start off with the square root. And if you start off with the square root, to undo having a square root, you raise each side to the second power, or in other words, you square each side. So squaring each side, you would get rid of the square root. A square root times a square root would just give you an x. Equals, and then 6 squared in this problem would be 36. So they're inverse operations of each other. So a radical equation is going to be one that has a radical over a variable. And probably the number one thing that you'll need to know is that you have to get the radical by itself. That's what that isolate means. Get the radical by itself. Then you're going to raise each side to a power and solve and check. Sometimes you do get something that's called an extraneous solution, and that means it's a solution that mathematically you did the correct work, but that solution does not check. It's an extra solution that does not check. So you do have to check your results. So I thought I would look first of all at a basic square root equation like 1a here, where we have square root of 3x minus 5 equaling 7. So what we'll do is notice that the square root is the only expression on the left-hand side of the equal sign. So that means it's isolated, it's by itself. And so we're going to raise that whole side of the equation to a power of 2, and the other side of the equation, the 7, we'll raise it to a power of 2. When you square a square root, the square root goes away, and you just have the inside. So we would have 3x minus 5 and our equal sign. And then on the other side, we'll have 7 to the second. Be careful that you're doing 7 times 7, which is 49. It's not 7 times 2, it's 7 times 7. And then you have an equation left that you'll have to solve. So this equation doesn't have an x squared in it, so all we need to do is work to get the x by itself, so we can add 5 to both sides. That would give us 3x equals 54. And then we can divide both sides by 3. And in doing that, we get x equals, and that answer would be 18. So x equals 18. You should check to see that 18 is actually a solution, and you can just very quickly in your calculators run that through. If you do the square root of 3 times 18 minus 5, and again, you can run that in your calculator, putting the 18 that you got in for the x, and making sure that that does give you 7. So you do want to check it. That's what I'm doing right here. I'm doing the check. And that does give me the square root of 49, which is 7. So it does check, and 18 is our solution. All right, so we'll move on. We'll look at a similar problem. And notice that instead of it being a square root, it is a third root. So we have the third root of 3x minus 5 equaling 7. So instead of raising each side to the second power for a square root, we'll raise each side to the third power since we have a third root. So the third power, and the third power will remove the third root, giving us still the 3x minus 5. Now, this time, it's not 7 times 3 either. It's 7 times 7 times 7. You may need a calculator for that, but that's 343. And then we can add 5 to both sides, giving us 3x equals 348. And then dividing both sides by 3, we get x equals 116. And if we check that, if we plug in 116, so if we do the check right here, the third root of 3 times 116 minus 5, we want to see if that's equal to 7. Now, real quickly, you can do that on the Desmos calculator. So if we bring up Desmos, the Desmos calculator, let me get that for us. The third root, if you use the scientific calculator, the third root is where it has this little n root. You can type in this third root symbol and then do 3 times 116 minus 5. And that does give us 7. So we've got the correct solution, and the 116 does check. So just be sure that you do that little check for your solutions. All right, those are your first 2 examples. We will move on and look at some other situations that occur while you are solving. So another thing that happens is that sometimes the radical is not by itself. And if that's the case, then you're going to need to add or subtract something to both sides of that equal sign in order for you to continue on. So in this 2a, I have a minus 6 that is not inside the radical, and I can't leave it that way. So I'm going to have to add 6 to both sides of the equal sign. Again, it's not inside the radical, so I have to move it to the other side. So this is now gone. That equals 6. And then I also have this 3 that is outside of the radical. So I'm going to have to divide both sides by 3 to get that to cancel, so that the only expression on the left-hand side of the equal sign is my radical. So 6 divided by 3 gives me a 2. All right, so now that I have that accomplished, I have a fourth root. I'm going to raise each side to the 4th power. And again, a fourth root will will be removed by a 4th power. So all you have left is the 2n plus 6. on the right-hand side, 2 to the 4th power. You are going to have to know how to do that on a calculator. It's 2 times 2 times 2 times 2, or using your Desmos, you can just do your 2, and you can use the caret, which is shift and 6, and then to the 4th power, and see that that equals 16. So use your calculator as you need it. So we get 2n plus 6 equals 16. Now we're just ready to do our algebra to get the equation solved. I don't know why I put 5. We want to minus 6 to both sides. And that would give us 2n equals 10. And then we'll divide both sides by 2. And our answer is n equals 5. A quick check. And when you do check, you need to always go to the original problem to do your check. So that can just amount to subbing in and actually typing it into Desmos if you need to. So for the check for this, we'll put in 3, and then we have the 4th root of 2 times our answer, which was 5, plus 6, and then minus 6, and we want to know if that equals 0. So you can either work that out by hand, or I'm trying to encourage you to use your calculator if you need it. So we have 3. We can put in our 4th root right here. There's a 4th root. I have 2 times 5 plus 6. And then I have outside of the radical the minus 6. And I need to see that that's 0, and it is. So I do have a check for this problem. On problem 2b, you'll notice that the radical is a 5th root. So when you're doing a 5th root, like before, I'll need to get it by itself, and then we'll talk about what power we would raise to. So I'm going to minus 4 to both sides of the equal sign, and that'll give me negative 4 times the 5th root of 16n plus 9 equals negative 4. I have this negative 4 outside of the radical, so I'll have to divide both sides by negative 4. So that's canceled. That leaves me with the 5th root of 16n plus 9 equals 1. Now, since I have a 5th root, then to remove that, I'll need to raise each side to the 5th power. So raising each side to the 5th power. Well, the 5th power will undo the 5th root, so I'll just have the inside 16n plus 9 equals. Now, my 1 to the 5th, it's tempting to say that that is 5, but it's 1 times 1 times 1 times 1 times 1. That answer is 1. Again, use your calculator if you need it. So I can subtract 9. That leaves me with 16n equals negative 8. I can divide both sides by 16. Now I'm going to get a fraction, or you can write it as a decimal if it's not repeating. This, I'm going to leave it as a fraction, is negative 1/2. And then we do want to quickly check that to make sure it does check. So we have negative 4. We have a 5th root. We're doing 16 times negative 1/2, our answer, and then plus 9, and then plus 4, and we want to see if that equals 0. So that last thing is a +4 there. So let's go to Desmos, and we'll check that out. So we have -4. We have our root symbol. So it's the 5th root of 16 times. You know, the nice thing about Desmos is it lets you put those fractions in. And then, so 16 times -1/2 plus 9. Outside of that radical, we have a +4, and we should get 0, which we did. So our answer checks, and we do have n equals -1/2. So those are your initial examples. If you'll turn your paper over, we have a couple of other things that do occur with radicals. So sometimes when you are working with these, the right-hand side of the equal sign is not just a number. In this case, the right-hand side of the equal sign is an expression. So this says be sure that you square sides, not individual terms. So when I say that I'm going to square both sides, I'm going to square that entire left-hand side of the equal sign and the entire right-hand side of the equal sign, not individual terms. Well, on the left, squaring a square root makes the square root just go away. So I'll have 2x minus 7. But it's not so easy on the right. On the right, I'm going to have to multiply using FOIL or your double distributive idea. I'm going to have to multiply x minus 3 times itself. So on the left-hand side, I'll leave it 2x minus 7 so that I can work on this x minus 3 and x minus 3. So remember, you take x times x to get x squared. You take x times -3 to get -3x. You have then this -3 that'll multiply by x, and finally the -3 times the -3 to get +9. So I'm going to go one more step with this. 2x minus 7 equals, and then on the other side, I have like terms that I can combine. The -3 and the -3 would combine to give me -6, and then x plus 9. So now you're going to have to recognize that you have an x squared term. When you have an x squared term, you have to get one side equal to 0. Get one side equal to 0, because you're going to either factor it or you're going to have to do the quadratic formula. So I'm going to subtract 2x from both sides. I want to line it up underneath its like term. I'm going to add 7 to both sides. So in doing that, this will cancel, and I'll have my 0 that I need. I'll have x squared minus 8x plus 16. All right, so now you're going to have to make your decision whether or not you want to try to factor this or whether you want to do the quadratic formula. I'm going to do this one by factoring. So my A is 1, my B is -8, and C is 16. So I'm going to make my chart. I need something that will multiply to AC, which is 16, and at the same time add to my B value, which is -8. So, you can make your list of multipliers to 16, 1 and 16, 2 and 8, 4 and 4. And out of those, to get +16 but -8, we would need both our 4's to be the same sign. So both negative 4 times negative 4 will give me positive 16, and negative 4 plus negative 4 will give me negative 8. So those are the numbers that I'll use to split the middle. I'll have 0 equals x squared, and then using my numbers that I found, negative 4x, and another negative 4x, and plus 16. We'll draw the cut line, and we can divide by x. And so that's going to give us x times our parentheses of x minus 4. Then on the other side of the cut line, I want to divide by the largest number that I can, and I have a negative third term, so I'll have to divide by a negative. 4 is going to be the biggest number that I can divide by, so I'm going to divide by negative 4, and when I do so, I will get x minus 4. I get that matching parentheses that I always look for with this process. So x minus 4, and it just so happens that my other factor is also x minus 4. And I've kind of been ignoring the 0. I'm going to go ahead and bring down the equal 0 because now we're going to solve. Normally when you have your two parentheses, you set each parentheses equal to 0, but the parentheses are the same, so I only need to do it once. So I'll set x minus 4 equal to 0. I'll add 4 to both sides, and my solution appears to be x equals 4. Even on these, and notice that this did take a little bit more work, even on these, we need to do the check. So off to the side, I will substitute in my answer of 4. I want to do it in the original problem. So the square root of 2 times 4 minus 7. Now remember, I have to substitute in the 4 wherever there was an x. So on the other side, I had an x, and I have to substitute the 4 in for it. So you can use your calculator if you need. This is going to give me the square root of 1, because I get the square root of 8 minus 7, and so that's the square root of 1, and I have to check to see if that equals 1. And if you're not sure, that's fine. Use your calculator. You can even go back a step if you needed to. You could put your square root in, and then the 2 times the 4 minus the 7, and that does give me a 1, and so my answer checks, and my solution is x equals 4. So there's your third example where you do have a little bit more work to do. And then finally, we have one other situation, and this would be where there are two radicals, and you have to make sure that you only have one radical at a time on a side of an equal sign. So in this case, I'm going to need to, I have a minus sign. I want to undo subtraction by addition. So I'm going to add the square root of t plus 2 to both sides of my equal sign. So here's my equal sign. I'm adding the square root of t plus 2 to both sides of the equal sign. So this is going to cancel over here. And then I'll have the square root of 2t minus 7 equal to, and then on the other side, I'll have the square root of t plus 2. So now my square roots are by themselves, one on each side of the equal sign. Now I will raise each side to the second power because they were square roots. And when I do that, the square roots go away. So I'll have 2t minus 7, and then also the square root goes away on this side. So I'll have t plus 2. So now you have a basic algebra equation that's got variables on both sides that equal sign. You'll want to get the variable on one side, so we could subtract t from both sides of the equal sign. That cancels. We get 2t minus 1t. That's going to be t minus 7 equals 2. We can add 7 to both sides, and our final answer is going to be t equals 9. We want to check and make sure that that does work. So the square root of 2 times 9 minus 7, and then minus the square root of 9 plus 2. And we just want to make sure that that equals 0. So using Desmos, we can type that in. So you've got your square root key, 2 times 9 minus 7, and then get out of the square root, type your minus sign, and then get another square root and do 9 plus 2. And that does equal 0, so our answer did check. All of them on this set of notes, the answer checked. That is not always the case. If the answer does not check, then you would just write no solution. So these are the different things that happen with your radical equations. This will go with homework number 6. So good luck with your homework, and ask questions as you need it.